All right, in this video, we're going to be covering creating a sequential circuit. Now, in previous videos, I covered the fact that an architecture could be either structural or behavioral. So far, we've only covered behavioral, but more specifically, we've covered combinational logic of behavioral architecture. Now, this is still a behavioral architecture, but instead, it is sequential logic. In this example, we're doing a register, simple enough. It's going to have a clock and a reset, and then we're just going to essentially set the output to the input. Now, if we come down here, similar to how there is synthesis coding guidelines for combinational logic to make a good synthesizable circuit, there are separate guidelines and different guidelines for the sequential logic. The first one being the sensitivity list should only have a clock and reset. If you go on to read, it technically shouldn't hurt anything if you include other signals, but they are not necessary. They can slow down a simulation, but needlessly retriggering the process and might confuse a bad synthesis tool. Remember, when I was mentioning before in the earlier videos where the sensitivity list, the way it works is that a process will execute anytime one of these changes. In a sequential logic circuit, we only want outputs to change on the rising edge of a clock. So if this process is triggering based off of other inputs as well, a process is going to be triggering uh, needlessly for no reason when we want it to be dependent on the clock. This way, it's only going to trigger the process whenever the clock rises or changes. The second synthesis coding guideline is that all sequential logic with an asynchronous reset should be described using the following basic structure here, similar to how it's being used right now. Another important thing to note is that any assignment to a signal on a rising clock edge will be synthesized as a register. This is really important when trying to simulate and specifically comparing to a test bench, and you might get an output wrong where your done signal, for example, is being asserted, a signal too late or a clock too early, that kind of thing. That's when timing becomes important, and it could be something with the register. Some other questions that I've been asked before were things like using an asynchronous reset or a synchronous reset. Unless asked otherwise for a lab document, I recommend following this structure. The differences between an asynchronous and a synchronous kind of go beyond the scope of this class, but basically for the synchronous, or sorry, an asynchronous resets, they're going to be more commonly used because they take less resources and the circuit synthesized and routed onto the FPGA is going to be smaller. Although, again, higher level concepts, although they are smaller, they're going to be less safe and are more susceptible to what's called metastability. So for the purpose of this course, unless stated otherwise, just follow this formatting. And then outside of that, that's basically it for this video. I highly recommend looking at Dr. Stitt's GitHub for the register. I really took out a lot of comments, but this is from Dr. Stitt's GitHub, and a lot of the comments go into really good details about some of this stuff. I just kept what I think should be known by everyone is very, very important. These synthesis coding guidelines. Make sure you understand those and apply those to any circuit you have. And in terms of trying to understand if you have a combinational logic circuit or a sequential logic, one giveaway is that if the circuit's given to you and you have an entity, but nothing's in the architecture, and there's a clock and a reset, it's going to be a sequential logic circuit, and you want to follow this format when creating the process. And then outside of that, a lot of times you're going to have circuits that are a combination between combinational logic and sequential logic. So sequential logic usually refers to the addition of a register or a flip-flop in that circuit.